Welcome everyone. It's great to see all of you. Um, if you are new, welcome to this vibrant C++ community. The fresh perspective you people bring is the one which will evolve the C++ going forward. So keep this enthusiasm up. And I'm looking forward to learn as much as from you. And in the exchange, I would like also to teach you something which I have learned over working with C++. So my name is Aman, and I have been working with C++ for over 19 years now. And I have been developing cross-platform applications for Adobe. And during this time, I have drawn deep into the intricacies of this powerful language. Today, I will be talking more about what limitations I ran into when I started using standard functions and similar constructs. These constructs are very powerful and they're highly useful, but they do carry certain overhead, which initially you might not encounter. So that's what I will be going through. But don't worry, I will just not review the problems. I will also share the solution, which finally we were able to devise and then get over those. So with that, let's dive into and take a closer look. But first, warning, the code is slide aware. So it's just so that it fits in the slides. There are certain things which I removed, but don't just copy paste. But yeah, takeaways that focus on concepts and patterns. Plus, please stay engaged and question whenever you have any question come up, and it's better to clear that there itself. So this is what my work looks like. So in Adobe, we have like a host app, and there are multiple service providers which can communicate with each other. Host app is only allowed to communicate with the service providers. And below the service providers, there are core modules and cloud services. So all the service providers are able to communicate amongst themselves as well as to the cloud services and core modules. And these are the two service providers I'm working on, which is CC libraries and cloud dots. And if we see the landscape on which I work on, this is the kind of products my code grows into. So starting from Photoshop, InDesign, Illustrator, on desktop to like new offerings like Fresco and Substance and all the video products. On mobile also the same code is consumed by Fresco, which is our drawing app, and whatever we have also ported Photoshop to mobile devices and even on the web. So the strategy most of the time is we use Wasm to compile our C++ code and then use it on the web platforms also. But I do work on JavaScript also, but not that much as much I work on C++. Now, if you see the service providers, so initially when we like 7 to 8 years back, each core service provider or each core module was able to generate or create on threads and work on that. And that actually bit us very badly when we started porting our code to mobile platforms where we are constrained with the resources. So the strategic step was taken that none of the core providers or the core modules will create any thread. So the host app during the initialization will provide 3 different task queues, which the core module is allowed to use to into the task on those. So first one is the synchronous task queue where we want it is a serial task queue where whatever concurrency you want to achieve within your data model, you can push all the tasks there and you will be 100% sure that they will happen in a serial ways. And then the background task queue is generally a concurrent queue where you can push long running tasks or the things which does not involve that your data model will be corrupted with that. And the notify task queue is the where whenever we get any notification, for example, from the cloud, we get to know that the cloud dot has changed or something has changed. And we need to provide the notification to our host app that something has changed. So that is the task queue for that purpose where we push all the notifications. And the last one is like rollback whenever our initialization is done. We let the host app know that whether we were successful or there was some issue. So taking that thing into mind, so let's take a little bit. How many of you love Lambdas? And if you love, you must be using it. So the Lambdas, like I have just put very simple examples of Lambda just to set the context. So these Lambdas are very simple. They don't capture the state. But when we are going to push a code onto onto the task queue, which can execute in a separate thread, we do need to capture state. So how we can capture state within a Lambda? So we can use the capture mechanism. But before going into that, all the captures, what actually happens behind the scenes, I will be using this instrumented class where if any move happens, I come to know because the ID will change. If there is a copy happening, the copy C will be appended. So this will be our instrumented class, which will help us understand what is happening behind the scenes, whatever we are capturing. Now, since everyone has used Lambdas, can you guess what will be the output of this code? Where I have like two instrumented classes, one with ID A and one with ID B, and I capture them. I capture them by reference, and then I invoke the Lambda. So what will be the output? And what will be the size? Any guesses? What is the reference actually? It's a pointer internally. So there are 2 pointers getting captured. So the size will be of the Lambda will be size of 2 word PTRs. And if we see the output, it is giving me that the A and B, which there is no copy happening, there is no move happening, and that is what we expected. And the size is 16 because my machine is like 64-bit machine. Now, if we change our code a little bit and we rather than we capture by value. So we change and we capture by value. Now what will happen? Any guesses? What? The output will be different. That's 100% here. Yeah, size of will be different. Will there be when I'm returning the IDs, will there be a change? Copies will be happening and the size will change. And perfectly just, there is one copy happening on A, one and a copy on B, and the size of Lambda has increased to 64-bit because each instrument class has a string, which is 32-bit and 32 bytes and 2 captures, so 64. So any questions till now to get the groundwork for the next stuff? So this is what Barney has written in his book. Lambda expressions are anonymous functions that can be defined at the point where they are used, and they make your code more concise and readable. And I think it captures the truths of Lambdas. But Lambdas are so cool, but can they be used as data member of a class stored in a container like queue or vector? Why? Because they return a closure, and the closure type is unique unnamed class type, and size is different based on the captures. So we can't store Lambdas as a data members. Now, if that's the case, we can't even use them in any task-based frameworks, as we need some type which we can control. We can't just pass a Lambda to the task-based framework that please execute this Lambda. We have to wrap it. And for that, stood function is the obvious choice, and we will discuss that a little bit also. So this is what my API, which I was supposed to work on the task queue, looks like. This is provided by a core module. There is some optimization which can be done there, but this is what I was living with. And so the task, a single unit of execution is a standard function which does not return anything and executes the code. And I can include my tasks onto this task queue. And then when I'm done, I can call shutdown on that. So that's my limitation within which I have to work with. Okay, any doubts till now? Okay, so little bit about standard function. It's a class template and it's a general purpose polymorphic function wrapper. Instances of standard function can store, copy, and invoke any copy constructible crawlable target. So by crawlable is where I can use the crawl operator on it. So it can store that. And under the hood, it uses type erasure to gain all the magical powers which it has. And it also utilizes small size optimization in case target size is within certain limits to prevent unnecessary dynamic allocation. So keeping all these things in mind, another thing, the targets can be functions, normal functions, or via function pointers. They can be Lambda expressions, bind expressions, other function objects, and pointers to member functions or data members. So that all it can store. Now, our goal for this whole thing is to schedule function on the task queue by moving all the relevant parameters and execute this function on the task queue. And once it is done, I'm also passing the crawlable function as the last parameter. It should crawl that function and let me know that what is the state. Any doubts till now that what is our goal from this? So on the task queue, we want to execute this function. And we need to pass all the parameters to this function, and then the callback should be in mode. So with this code, I have a by value class, by reference, by constant reference, because I'm taking three parameters, if you see, which I'm the instrumented class by value. Another one was by reference. If I go back. So first one is by value, the second one is by reference, the third one is by constant reference, and the fourth is the crawlable function. Okay. And now if I am doing this, where I have like 3 classes, and as I need, and want to add a little bit complexity, even the callback Lambda is capturing one of the instrumented class instances. Okay. And when I'm invoking, if you see that when I'm entering this task, I am moving the value. I am moving everything because it has to go onto a separate thread and then execute it there. I can't just pass the references because that's the idea that everything is patted as everything together and then push to the task queue and then task queue will execute. So any guess is what will be the output? Or do you think there will be a copy involved? I am doing the move. Will there be a copy involved? How many think or guess copy will be involved? No guesses. And 2. And how many think will there be moves involved? And how many? More than 5? More than 10? Less than 5? Okay. So let me give you the results. With Visual Studio, with release configuration, this is the number of moves and copies happening. And on client, it's even more. So we are having 2 moves on by value, then 2 copies, then 2 moves on reference, a copy, 2 moves on constant reference and copy. They both are same. By reference and constant reference are same. And on captured, we have 3 moves followed by 2 copies. And on planned, the capture one actually has like 3 moves and 2 copies followed by a move. So 1 extra move is there. Did you anticipate these many moves? And even the copy, I am using everything. I am saying I don't want these classes, these instances anymore. I am doing the move, but still eventually it ends up having making unnecessary copies. And this can happen because when I was getting response from the cloud services, the JSON was like sometimes 30 MB, 40 MB, and I had passed it. and then the whole DOM was getting copied unnecessary, and it was happening multiple times. So that was the problem which I wanted to solve. Okay, so removing. So if you see, there are two copies happening on by value and even on the captured object. They were pretty easy to solve. I can remove one unnecessary copy by just changing the code a little bit, which was actually bad on my part. If you see the last line where I'm calling the async function, if I just, rather than saying move, so this was the cause of the second copy happening. So rather than this, I can just say move these things. And then the output, which was copy, changes to move. So at least we prevented one of the unnecessary copies, and that was in our hand. So that was easily possible. So now summary so far. We have established that the standard function is the signature for each task unit, because there is nothing else we can use as of now. But there is no need for copies to be made of our data, and we must get rid of. That's our goal. We don't want these copies happening. And there are so many move operations happening. Can we define the optimum number of moves which should happen, and can we achieve them? So this is what till now we have, like what answers we have, what questions we have, what we want to achieve. Any questions on this? All good? Okay, great. Now, before going to the solution, let's compare other constructs. And for that, for the time being, we can leave that I'm going to execute on a separate task queue or a separate thread. I can just say that the bundle should be like this, that everything should be captured by value, means they should have the copies and then they execute. So for this, I'm using two functions. One is func, which again uses one by value, one by reference, one by constant reference. I've just got rid of the callback to ease a little bit to understand the things. And the function two, later you will realize that function, the first function in some of the standard constructs we have are never able to call the first function because of pass by reference, not by pass by constant reference, but pass by reference. So that's why for those scenarios, I'm using the fun2, which just removes the pass by reference, the middle parameter. Okay, any doubts on this? This is now for like next 3-4 slides. Just keep in mind, there is a function by the name fun, and the other function is fun2, and they have like 3 and 2 parameters. And the whole purpose of those functions is spit out the IDs, what I'm writing at that time. So Lambda versus standard bind. So we knew Lambda, how it works, and we know what will be the output. So I moved all the 3 instances, and then because I want to use move, I have to use mutable on this. And on the bind side, bind can't directly work with fun, because you can't bind R value references to L value references. So we will go into a little bit into detail of this, but there is a problem. That's why fun2 was introduced. Now, it's very easy to guess the output of Lambda. What do you think about standard bind? So by Lambda, we know there is one move happening when we are capturing the first one on second line. So if we just consider the first parameter, and the second one we are saying when we are calling function that please move it. So 2 moves, perfectly logical. And on the reference, the second parameter, we are just doing 1 move and just passing it to the function. So first and second parameter, only 1 move is happening. So no surprises there. But with bind, I'm moving by value, but when it is crawling, it is doing a copy, and there is no way I can prevent that. So that is the biggest drawback of using function if you are doing anything pass by value and you're trying to capture it. Even though I said that please pass by value or move it and then pass it by value, it is making an unnecessary copy. So standard bind has this I will say, issue that it unnecessarily creates a copy, even though it has like a actual instance with it, and it no longer wants to use it. Might be it's because we can crawl this bind, whatever it bind is returned in multiple times, but there is no way where I can say that this is the last time I'm crawling this construct. Please move the things rather than making a copy of the things I have passed to you. So be careful with this if you are using bind in your code. Now, let's look at standard async. So again, I move everything and then ask async to just execute this code in a separate context. And it's done pretty good. If you see 3 moves, 2 moves on the references, and I think on clan, there is like 1 extra move always. And in clan, because it adheres to the actual standards, I will not be able to call fun on that rather than fun2. Why? Because I am moving by reference, so it has a R value reference. But if you see the signature of fun, it is a L value reference, so it can't match an R value reference against an L value reference. But Visual Studio do allow this non-standard extension in their code base, but it should not be actually the right way to do. Okay. Any doubts till now? Okay, great. So the summary of comparisons till now. So Lambda provides us the maximum flexibility and performs quite well. There are no surprises with Lambda, and it is able to do the things which I want Lambda to do. Standard async can execute our code on a separate thread, so no copies are involved. Implementation on Windows give us the lower number of moves, but we don't have much control on execution context because we can't say on which thread you do and execute, or if I'm in a task-based, task queue-based framework, I can't ask that please execute this on this task queue. So that's the problem I have. But standard async is what we should try to achieve, where there are no copies happening unnecessary and minimum number of moves. So let's set our gold standard based on standard async. Coming back to the old one where even in the callback, I'm capturing something. And now using the async, I'm asking this to be executed on a separate thread. And let's see what standard async returns. So this should be our gold standard, and that is based on Windows. There are, like previously, we see 3 moves, on by value, on references 2 moves, and on the captured thing, we have 4 moves. This should be our defined set of number of moves without any copy, with whatever solution we devise. We can't go more than this and then say our solution is good. Agree with this, or any questions till now? Yeah.
So why are there moves at all for the references? Like, shouldn't we just be able to pass those in as references all the way down?
Yes. So I'm saying, if you remember, we are going to execute this whole thing in a separate thread. If really I know that the lifetime of this particular object which I'm passing will be there, I can pass it with as a reference. But what I'm saying, please do and execute. You are a complete package. The function is written in such a way that it is using something by reference or by const reference. I don't care because I don't know this object. You needed it for your purpose. I provided you the everything. Now do and execute it. So that's why even there we are passing it, moving them, and then letting the function execute on those. Any other questions? Good. So summary so far. First one is done. Still we are, with our solution, whatever, we haven't yet be able to resolve copies. But what we have been able to establish is we have defined the optimum number of moves. Like we said, 3, 2, 2, and 4 on the captured one. And we haven't achieved those optimum numbers of moves with our solution because our solution was, it's not working. It's like having a lot of moves and copies. Now the problem is when we are capturing data. That's the issue. That when we are capturing the data and bundling, letting the Lambda wrap into a standard function with all the captures, standard function is resulting in those copies and unnecessary moves. So I thought, let's capture the data separately. So I created a container. So what I needed 3 instances and a callback function. And so I created this, wrote this holder quickly, and then I don't need it, but I wanted it on a heap so that none of the copies and moves happen. And I made a unique putter of it, all the bundling everything together. And then I tried to enqueue this. Will it work? Have you used unique putters with standard function? Do standard functions carry a unique putter or anything which is not copyable? That's the issue with the standard function, that you can't pass anything which there is no copy operation available on that. And if you see in C++20, we have move only functions, but till the time we were stuck with C++14 and C++17, we didn't have that. So because of this, I am forced to, rather than creating a unique putter, I am forced to use a shared PTR, which has its own problem. I don't need the reference count. Unnecessary reference count will keep bumping 1, 2 whenever there is a copy being made, and then in the same thread reduce it to 1. But those atomic operations will have some issue, means it will have some performance issues. But for time being, let's say we are stuck with shared PTR and we run this code. What do you think? Will we be able to remove all the copies, and where we will be with respect to moves, number of moves? Okay, will be able to solve copy problem? Any guesses? So you are putting everything into unique putter, and then you are passing it across to the different thread. The unique putter is doing all the, shared PTR is just doing, the data remains there itself at one location. Will there be copy involved? Yeah, shared PTR is fine, but of my data, which can be huge.
I would say no.
You will say no? He's perfect in that. So if we see our solution, on the left side, we are just left with 2 moves on the pass by value thing. On the reference, there is just move because we are moving those things. And on the capture, we are down to 3 moves, no copy. If you see the middle part, that was Windows and clan. And on the rightmost side was standard async. So have we achieved what we wanted? We have got rid of the copies. We have actually battered what we set our as gold standard with respect to moves also, by just wrapping it in a structure and then making a shared PTR out of that. What do you think? Is the solution good or not? But are you happy? When someone forced you can't use unique putter, but you have to use shared PTR. Are you happy as a programmer, as a designer, or as an architect? No. If I don't need, why I should pay for it? I am in that habit. If I don't need certain functionality, I should not be paying for it. And with shared PTR, the biggest problem is reference count being atomic. They actually have a lot of performance implications because the synchronization needs to happen of those atomic counters. So, summary so far. We have established standard function. We have established the number of optimum moves, and we have actually battered it. And there are no copies involved, all 3 green. But the problem which we now started on is standard function is forcing us to use shared PTR, and the code is not generic enough, because if I have to call another function, I have to again spit out another structure with all the fields, make a unique PTR and all that stuff. I have to, if the function is different, I have to rewrite the whole code, which I don't like to write the same code again and again. Now let's first try to solve where standard function is forcing me to use shared PTR rather than a unique PTR. One thing what we can do is, rather than doing anything, I can just pass the raw pointers and delete it at the last one. But as a good C++ programmers, we should not be working on raw pointers. So that solution we will keep aside. We will not even discuss that. So I spit out a small MoveWrapper, which is nothing but a very lightweight container. The only purpose of MoveWrapper is whenever there is a copy constructor crawled on it, rather than copying it is making a move. So copy acts like a move. And it's not just I have it in my code base, even though I don't want it to be exposed to everyone in my team, who don't know what MoveWrapper is actually doing and what was the purpose of it. But even if you see Folly, they have a MoveWrapper also. So it's just a very simple that it stores the value, whatever it is being provided, and then whenever copy constructor is called, rather than copy, it will make a move on it. And for that, the value is mutable. Any questions on MoveWrapper? Yeah.
Can you go over why value needs to be mutable?
Okay. So if you see the copy constructor, the source is constref. So I can't move the things so I either I typecast it to non-const, or I can make this thing mutable. But be very careful. Don't expose this to everyone. If you need such kind of wrapper, keep it hidden with the warnings. Okay. But yeah. So now with this was our previous code where we were using mate shared. And if I now see, there are two changes done. When I'm creating a holder, I am making a unique putter and a MoveWrapper. I can do it in the Lambda also, but I just wanted to highlight the differences. And in the capture, I'm rather than capturing the holder, I'm capturing this wrapper and moving it. And in the code, I'm just making that, let me get the holder back, a reference of it, and then just call the async fun as it is. Okay, so now I'm not forced to use a shared PTR. Any questions on this? Yeah.
Haven't you just, made a whole lot of danger involved with that MoveWrapper? Because now, if you're making the assumption that the new one is always the one that's going to be used, but if a new one gets created and then destroyed immediately, you just destroyed your object, as opposed to.
That's why I said MoveWrapper. Don't let everyone take it. But if you see in this context, because everything is getting passed down the line, here it works smoothly. There is no chance I will be running into that issue.
On this version of standard function.
Yes. So that's why I said, don't let everyone use it. But yeah, just for the time being, think this was like a ad hoc solution. I don't want people to use it that often, but this is one way where we know I am moving something down the line. It will be only one owner will be there, but because of some restriction where unnecessarily someone is making the copy, but that anyways, two copies will be moved, one will be destroyed there itself. So let me move it, and there it makes a good candidate. And that is our use case in this case. But you are right. That's why I said MoveWrapper, I am not happy with it when I wrote it. And then I somehow found it that Folly has it. I was a little bit satisfied. Okay, someone else is also using it and there's a use case of it. But still, I keep it very hidden, put it in a namespace, like warning or not to be used always. So I have the habit of putting all these things where something is like happier for a particular thing. I don't put it in outer namespace. I just wrap it in a namespace so that everyone is aware that these classes should be used where they know that what is being done with that whole thing. So yeah, you are right. MoveWrapper, if used in some other context, can lead to that problem. Any other questions on this? Okay. So the summary so far, just we are no longer forced to use shared PTR. And the second part, which I said, the code is not generate enough. Can we make the code generate? So couple of things. There is one thing in STL which we can use to bundle all the different parameters of a function together. And what is that STL provides us? The tuple. Tuple is a heterogeneous container where we can put anything, and that is what we can use. I can write a small make unit tuple function which will create a unique PTR of tuple for me. And then I just say make unit tuple pass everything to it. And then just keep in mind, I am not now able to call async function which has a reference, non-const reference, but I'm only able to call async fun2 with tuples. But we will solve that problem also. But this is just like a one step to make you understand that how tuples can be used to store the value. So if you see when I'm creating tuples, I am detaining the type of the arch so that everything in tuple is stored by value. It's not, if I just pass some reference, it will not be by reference. It will be like the actual value. The tuple will contain actual value. And then I can use standard apply to call my function, but you see the machinery which I need to do. I have to call move on dereferencing something on empty.value, so all that thing. But it does the job for me. For async fun2, it does the job for me with tuple rather than creating all those structures by hand. I can rely on that. But it has a problem that it can't be used for functions which have non-const references. Even though it is not, generally it is destroyed, but even if you see C++ standard do have some functions which take parameter by normal references. Okay. So it can be a genuine use case, so that's why we do need to solve that problem also. So standard tuple looks nice, but let us wrap it in a holder where we just have one data member args, which is just a tuple of decayed types. And while creating holder, I just forward everything to the tuple, and I provide a very handy function on that which says invoke, and invoke will just say, give me the function and I will use those args and invoke it for you. And to help us in creating this, I wrote a small function make unique holder, which returns me a unique putter of this. And I can use this holder rather than directly dealing with tuples. Okay. Now, the code looks like this now. Just when when I'm creating the wrapper, I am using, so this is the old one. It will change to this one. So this is the old one where I'm using this that's reduced to this one that I'm saying just make a unique holder for me. And then once in the Lambda, I'm just saying, please invoke this thing with the async fun2. So any questions on the generate holder? And mind you, there is no change in the number of copies or moves. It's still the same. It's 2 moves, 1 move on the references, and the 3 moves on the captured reference. All the code, both on Windows and Mac, works the same way with the same moves or copies involved. But this is where we are trying to get to the solution. Now, the code is generic enough, but it does not support functions with non-const reference, and even on Windows. Whereas previously on Windows, we were able to call async fun using some of the standard construct, but with this approach, even on Windows, we are not able to crawl because the standard apply doesn't even work on Windows. So this is where we are right now. Okay, now let's see what we can do further. But why we are not able to crawl standard apply when a function has a reference? As I told you, we can't bind R value reference to L value reference. And if you see what type I have for my tuple in that holder, what was the type? I told you I'm doing decay on everything, so that the type I have in my holder, all the 3 instances are by value. So they are instrument class, instrument class, instrument class, followed by a callback function. So everything is by value. That is the type I have in my holder. But what function needs? Function needs first type as by value, the second one as reference, the third one as constant reference, and the callback function, even that is constant reference. That's around here. But this is the problem, that the type I have and the type applied and worked on are different. Okay. So if we can solve this problem, we are able to call the functions with the references too. Okay. So the manual solution is very simple. So once I have the odds within that, I can convert the odds into my want type by calling move on the first parameter, just giving the reference to the second parameter, giving the reference to the third parameter, and moving the lambda and convert it into a callback function, and then calling standard apply even for functions with non-const references. This thing will work. Okay, so this is how we can solve even for the reference. Any questions still here? Yeah.
Can you use, I think it's called STD edge reference to that?
STD?
Edge reference, I think there's some.
So there is a reference wrapper there, which I have.
You can add reference to your.
Yeah, I can do that, add reference rather than saying.
Right. And I wonder if the STD get has any performance implications.
No, it just gives you the reference directly. Any one, another? Yep.
Is it required to make a copy in the one type to cause the individual parts to the individual types?
Can you repeat?
Is it required to make a second tuple?
Okay. So second tuple is actually not it's not cropping the instances at all. It's just saying that I have either a R value reference to something which is there at separate place, or I'm having a reference to something at a different place. It's just like a tuple of references. Either it is a tuple of R value references or a tuple of L value references, but the data actually is in the old tuple only. It's just a tuple of references, which we will later know forward as tuple does the same thing for me. Okay. So this is what if we are able to do. Our first problem means our problem is solved, that even I can use this mechanism to call functions with references too. Okay. So now we support functions with non-const references, but it is lot of boilerplate code. And every time, whenever I am stuck with function, what is the type of the function, I have to hard code it. So if you see, I have to hard code what is my want type, and even in the standard apply, I have to do all this magic. Or on something I have to call move, on others I don't have to call it. So it's still lot of code every time I have to write if I want to invoke a function on another thread. Okay. Let's see what we can improve there. So for automated solutions, we need two things if we want to get rid of this. First, we need to know the exact type of the parameters of a function. Then only I can say, if I know, oh, this is the first parameter is of by value, the second parameter is by reference, the third parameter is const reference, and so on. If somehow I can programmatically know that, first thing. Second is once I know that, how to convert tuple of values to tuple of types required by the callable. Okay. Right now, if you see, I have to do each parameter one by one. Can we devise solutions for these two problems, and then we are done. Okay. So the logic for converting part we will do first, which for me, I thought it was easy. The logic is very simple. If the parameter type in function is by value, my tuple at that particular slot should have a R value reference. If it is a by reference, my tuple should have a L value reference. What we did there. So it's the same thing what we are trying to achieve, but just putting the logic. So this is a very simple code which we can use to do this. Okay, so let's do it. I'll try to understand. First part is important, which is conditional move. What it says, see, look at the return type defined. It says if it is a reference, okay, return a L value reference. If it is not a reference, return as a R value reference. So the second line, if you see. And even though the intern code is not required where it is the return type which was required, but to compile it, I just put, if it is reference return key, if it is a non-reference return, just typecast it to R value reference. That's it. So first thing is very simple, but that's the crux of the thing. That defines whether if I am passing a reference, the return type will be a reference. If it is passing by value, the return value will be R value reference. First part clear. The second one is just which is doing the whole thing. So what it says, the class T is what kind of tuple I need. What is my source tuple, the second part. And the third is just when I'm using it to work on each element. So that's the magic we use, where we use the index like this. So it says that forward as a tuple, and it uses conditional move on each element now. So that if you see 1, 2, 3, 4, 5, 6, 7th line, I think, where I'm using conditional move, it is using conditional move on each element. It is actually expanding the tuple into each element and then just packing it using forward as tuple. So that's it. That's the whole tuple machinery is doing for me. Template machinery is doing for me. And the last one is just a simple, or I will say a helper, where when you create a tuple converter instance, it takes the reference of the source tuple, that what is my source tuple, and then you call convert on it, that what should be my destination type, and it does all the magic. So my code, whenever I am writing it, I am just working on a tuple converter, not on top two. So any questions on this? Even though it looks, there's a lot of code, but it's very simple to understand that what it is. First one is on each element of a tuple. The second one is actually breaking the tuple into separate elements, what it has. And the third is just a helper. Okay. Now, using tuple, this was our old code where I was creating tuple. I have to give the types. This gets reduced to this. So if you see standard apply want type, I just say tuple converter, this is the source tuple, convert it into want type. It does the magic for me. I don't have to, just have to define the types at one place. I don't have to manually do move on those things, and still the performance remains same, everything is same. We are just using template machinery to generate that code for me rather than me doing it every time. Any questions? Yeah.
I think that, is this CVP 14 or 17?
C++14. Everything works from C++14 onwards. Because at time when I wrote this code, our code was C++14. Now we have moved to C++17 and
So in 20, I think it could be modernized.
yes, it can be modernized. Yes. Yeah. Okay. Any questions other than that? Okay. So summary so far, from lot of boiler code, we are left with some boilerplate code. And the boiler code is, I still don't like where I have to specify want type. As I told you, there, if we can devise a solution where I can even find the type of a function, what are the parameter types, it solves the problem for me. So let's see how we can do that. And this is a code which can do for me. So you define a base template class, function traits, which doesn't have any members. And then you say there is a templated thing which matches a function, normal function. R is the return type and R can be anything. And then it returns me a tuple of those R's. And to make things even easier, I don't have to write type name every time I'm using. This is just which does the deduction for me, type deduction for me, and makes the code very easy. The function which is using function traits R tuple T. This is what even standard STL uses at a lot of places. So rather than using type name, now each class is like underscore T, or if it uses value, the idea is to use underscore V. And if I run this code, and I run it on async function, which is on the 4th line from bottom, you will see the function type I can deduce from this. And if I write expected type and do a static assert, they are exactly same. That means this template is able to give me the parameter types of my function wrapped in a tuple. And that is what I wanted. Okay. So now plugging in that, so this is the old code we have. I don't have to write types. I just say, go deduce it for me. find the want type, use it, use the tuple converter to do it for me, and I'm done. So we are, why it is not working? Yeah. I'm happy, but still very less boilerplate. Can we do something better? Yes. So this was the old code. Sorry. Yeah. So this was the old code we had. If you remember when we started using generate holder, the first time when we wrote those holder by hand, and then we used the holder which had a tuple, and then we provided a very small utility function invoke. Okay. Now, if we modify our invoke, which is this one, this was our old invoke. Okay. If I just add these lines to it. So I'm saying the destination type of the tuple, do find it from the callable, because there I was passing that async function, and this should be the destination type, and do it. So I don't have to even find the use function traits in my code. So if I do this thing, the code which was like this reduced to this one single line. Because all that logic, all the code which was I'm doing here, I push it to the invoke. That go figure out the destination tuple type, go convert it, and then run it. So now this is the only we have to create the holder and then just say invoke extended. How do you like this solution? Okay. So we have no boilerplate codes, put functions, everything. So we have tick marked everything. But someone said MoveWrapper. We are still using MoveWrapper here. We are writing that when we are creating this, create a unit putter, put it in a MoveWrapper, and then use it. And I don't want everyone to play with MoveWrapper. Can we do? Okay, one thing before we go into this. What about memory allocations? So we are creating a unique putter. Will it increase the memory number of memory allocations? Will unique putter crawl a new or not? It will. So do whatever we have done, will it increase the number of memory allocations or not? Yes. Anyone? Other yes? Anyone no? Anyone reduce that we will, whatever calls were initially, we are getting lower than that. No, not from that. What I'm saying, from the old thing where we were able to put it in the data was just wrapping. So from there, but yeah, we are saying because of topics we have done better, but we are actually reducing the number of calls. Why? Because if you see, standard function is able to not use the memory allocation only if the size of the captured or the callable is within certain limit. And since we were capturing 3 instrumented class and a callback function which has again another instrumented class, and it was doing the memory allocation behind the scenes, and it was doing multiple memory allocations. I don't know why, but it was doing 3 extra memory allocations when I debugged it on our release configuration. On debug, it was even more. With this, we are only down to 1 memory allocation. And when we are wrapping it within a Lambda, it is of 1 void PTR size, which is much lower than whatever is the small size optimization standard function has done. So actually, we are reducing the memory, dynamic memory crawls also. Not only we have reduced all those copies and moves, number of moves too, but we are even better on the memory allocation part also. Okay, just wanted to highlight that. Now, everything done, we were good with the approach. I thought movable wrapper, that was always my concern. So rather than using a holder, I am saying functional. And if you don't, I tricked you in one of the things. If you remember, I was initially capturing the trollback lambda, not the trollback as a function, but as a lambda itself. And when I'm going to troll it, the signatures was a standard function, not a lambda, because we can't have lambda in a interface. So internally, what was happening from that lambda, a standard function was getting created. And since that lambda, if I forget to troll move on it, the copy of lambda will be done. So on the captured object within that lambda will be copied. So at one of the things I just started doing move, but that is one thing which we messed there. So how to solve those things? The problem is with whatever holder approach is, holder type is based on the what you are passing it to. For example, I said move the first instance, move the second instance, move the third instance, move the fourth instance, and fourth one was trollable, lambda. So our tuple, rather than having a trollable function, was having a trollable lambda. It was not the type which function expected, it was the type which I passed on to it. And if I do mess up there, I still end up having one or two copies. So to solve that, rather than doing that, what I did is I had a function holder and it is parameterized on the function type. It is just parameterized on the function type. Odds are just what it is storing. And now I need two things. I'm even capturing the function which I need to call. You don't need to provide me the function. So I need copy, if you see on the 1, 2, 3, 4, 5, 6, 7, 8, 9th line, 8th and 9th line, the data members of path, the first thing I am capturing is the function, which function to call. Okay, and I am saying create a tuple. Okay, but that tuple is not on the type of odds, if you see. That is based on the parameter path of the functions, what parameter is required. So at this time only, all the conversions on the things happened there itself. And this odds is actually a tuple of the type my function needs, but everything by value, not by reference, but everything by value. So that is the thing you have to keep in mind, that this is the thing where all the magic happens in this. And then MoveWrapper is right here, will not be exposed to the clients. Yeah. Yes. So function handler, just if you see, it creates a unique, but my content is a MoveWrapper, so automatically MoveWrapper is now encapsulated in this function holder, and invoke is the same thing. Only I have just changed a little bit, and then rather than having mate holder or this, I added another mate function holder class which takes the function and all the arguments and then paths everything. With this was our old code. See, that was the I am highlighted yellow code. That part I was doing because I was converting lambda to a actual callback function so that the move happens there itself. It's not that it is captured and then it is. Now with this, I don't need to specify anything. I just say make function holder, pass the function there itself, that this is my function I need to call, move everything together, and here I'm doing the move on the lambda itself. I'm not even making, everything is done by the code automatically. This lambda is actually converted to callback function, and then when I invoke, the same thing. So the code is now just left to these lines, and it can work on anything, and the same thing can be even extended to memory functions, or member functions also, if you want. If you want to call member functions on an object, the first parameter can be either a pointer to the function or a shared PTR or a unique PTR, and everything will work there also. So yeah, that's it. So there is no movable wrapper, no boiler code, no movable wrapper or unique pointer creation exposed to user. User doesn't know whether there's a unique pointer being created, a movable wrapper being created. That is all hidden within one class where you can be sure that no one else is touching it. So that's it. From my side, I was happy with when everything came down and then the code written was very small. But yeah, this is what my experience was with using standard functions in a asynchronous framework. Any questions? Yeah, go ahead.
So in this approach, if my objects are already on the stack,
Yeah, you can use the mic, please.
yeah, so in this example, if the objects that I eventually want to pass to the async function call, if they are on the stack, since this implementation uses a unique pointer, I'll need one heap allocation for them, right?
Only one allocation is done for the whole
Okay.
path. Now coming to your point, if you know my lifetime will be there till the time asynchronous is there, and I really want to pass a reference from my this thing, just wrap it within a reference wrapper, and everything will work as it is, without any problem.
Thank you.
Yeah, yes, sure.
Just curious, if your enqueue function was templated, would it be possible to have some optimizations there? Because now you could put in the Lambda directly as opposed to the std function middleman.
Yes. So one good point is, so now that's why I have started doing that. If we go to the task UPTR, sorry. Come on. Yeah. So here, the question is, if rather than having enqueue, if it is a templated function, one function has to be there which takes a standard function. But rather than taking by const reference, if it had taken by value, and if someone passes this as it is, there will be no drop involved, even though we will end up having a lot of moves. Okay. And to come into your point, if this is templated, on top of that, we also have enqueue functions which are templated, and there is only one function, private, which takes a standard function. That also solves a lot of problem where unnecessary moves on the Lambda will be minimized. So that's why if you see the approach in all the STL, all the constructors are templated, and they use standard forward on that to make everything universal references, so that everything till the time you actually want the conversion to happen passes as it is till the last moment. So yeah, good point. So yeah,
Thank you.
yeah. Any other questions? So thank you everyone. I hope someday you will use some of the ideas and it will be helpful to you. Thank you all. Thanks.